When we interact with an AI chatbot, it looks like a simple text exchange, but underneath that clean interface, your input shatters into hidden data streams, telemetry networks, and tracking codes. Professionals have come to treat these models as a private workspace. We paste in proprietary code to debug it or draft sensitive internal memos, assuming the interaction leaves no trace. But a recent wave of source code leaks and API errors from Anthropic's Claude has begun to reveal a different reality. Driven by new global regulations, major AI companies are now weaving invisible tracking mechanisms into every stage of the user interaction pipeline. Every prompt and every response is now part of a chain of custody that spans from the user's terminal to the regulator's desk. To see how this works, we have to start at the very beginning of the technical lifecycle, the moment you hit send on a prompt. Before the model formulates an answer, it employs a technique called prompt-steganography, embedding hidden instructions within the communication flow to silently monitor the user's environment. Through these hidden instructions, the system extracts parameters without the user's explicit interaction. It logs your time zone, notes your proxy status, and identifies usage patterns associated with specific research labs. These triggers allow labs to detect unauthorized use and prevent competitors from distilling the intelligence to train rival models. It transforms a simple, benign text prompt into an active telemetry signal before the AI has even processed the request. Moving deeper into the pipeline, we reach the processing phase. Claude's extended thinking feature was designed to show the model's reasoning before delivering a final answer. But very recently, developers encountered a roadblock. Their automated workflows started crashing with API 400 errors, citing messages that could not be modified. The leaked source code pointed to the cause: redacted thinking blocks. These are internal reasoning steps that the AI is programmed to hide from the user. These blocks create a hard boundary within the model's reasoning. They allow the AI to calculate internal constraints and crucial safety protocols that remain entirely invisible to the human operator. This architecture ensures that even when the model appears to be showing its work, its most critical governance logic is withheld by design. The final phase of the pipeline is the output itself. The catalyst for tracking this text is the European Union's AI Act, which requires synthetic content to be detectable by August 2026. To comply, Anthropic uses statistical token biasing. A cryptographic key divides potential words into green and red lists, favoring green tokens during generation. Because this signature is woven into the words themselves, it survives when copied and pasted elsewhere. This provides a level of durability that C2PA file metadata lacks. Metadata is a signed label, but it can be stripped by simply taking a screenshot. However, the technology is limited by entropy. Flexible prose offers many equivalent phrasing options to easily hide a signal, but rigid text like source code simply doesn't. In code, the watermark often fails. Changing even a single token can break the entire program. Every response now doubles as a machine-readable fingerprint, a permanent record of corporate AI involvement woven into the text itself. Zooming out from the technical pipeline, we can see the broader shift. Users seeking invisible assistance are now operating within a framework of accountable infrastructure. This has triggered a backlash from developers who realize that their proprietary code and documents may now carry a persistent, detectable trace of the AI provider that processed them. There is also the risk of misinterpretation. A watermark is only a signal that an AI touched a document. It cannot prove who originated the underlying ideas or did the research. Even so, the rollout of detection APIs and platform-wide monitoring is turning this tracking into a permanent layer of the global digital landscape. To navigate this new environment, users must design their workflows under the assumption that the invisible ink is always reported.